Hello, in this video we are going to see what is time scaling operation. Okay, so let us consider a signal. Now the signal phi of t, let us consider another signal which is known as phi of t, and this is from t1 by 2 to t of 2 by 2. Okay, so this is a signal phi of t which is from minus t1 by 2 to t1 by 2 to t2 by 2. Okay, now this signal phi of t is the compressed version of this signal. So this is so what is time scaling? Time scaling is basically signal expansion or compression is known. Now this signal phi of t is time, this compression in time, and it is given by phi of t is equal to x of 2t. So it is scaled by or compressed by 2. Okay, so now you can see that whatever is happening in this signal at t1 is happening in this signal as t1 by 2, and whatever is happening here at t2, now it will happen in phi of t as t2 by 2. Okay, so this is compressed by a scale of 2. Okay, this is equivalent to saying that if you record a tape and then you play back it at twice the normal speed, what you will get is phi of t. Okay, so the x of t was original tape, and if you play it back with twice the speed, then you will get phi of t. Okay, and in general, if we compress x of t by a factor of a where a is greater than 1, then we will get phi of t equal to x of a into t. Okay, if we expand x of t by a factor of a where a is greater than 1, then phi of t, the expanded signal phi of t will be x of t by a. Okay, so this is the expanded signal by a factor of a. Okay, and this was the compressed signal. Okay, so both expansion and compression is known as time scaling. Okay, means this is equivalent to saying that the signal x of t is played back with the speed 1 by a, or means it is slowed down. Okay, so for example, if a is 2, then the expanded signal phi of t equal to x of t by 2 will look like, the amplitude will not change, but it will be from 2t1 to t2. Okay, it means whatever is happening in this signal at t1 will happen in the expanded signal at twice of t1, and for t2 it will be twice of t2. Okay, remember that in the time scaling operation the amplitude remains unchanged. Now if we summarize the time scaling operation, we can see that to time scale a signal x of t by a factor of a, where a is greater than 1, we replace t by at. Okay, and here if a is greater than 1, then this operation will result in compression by a factor of a. Okay, and if a is less than 1, then it will result in expansion by factor of a. Now let us see an example. Okay, so this is the problem, and we are asked in part A to sketch and describe the signal compressed in time by a factor of 3. Okay, and repeat part A. If x of t is expanded by a factor of 2, we have to describe it mathematically. Okay, so let us solve this problem. So I have copied this problem here, and so let us see the solution. Okay, so let us solve first part A, in which we are asked to describe this problem by if it is compressed by a factor of 3. Okay, so first we can write this equation of this x. So our x of t will be x of t equal to, so this is 2 when t is between -5, -1.5 and 0. So this is 2 when t is in this range. Okay, and it is 2 to the power minus t by 2 when t is in this range between 0 and 3, and it is 0 otherwise. Okay, so now we have to find the compressed signal x of 3t. So our compressed signal, let us call it xc of t, will be equal to x of 3t, and we can find it by putting 3t in place of t in this expression. So it will be 2 between -1.5, 3t to 0, or we can write this as -0.5. So if 3t is between -1.5 to 0, t will be between -0.5 to 0. Okay, and when t is between 0 and 3, so x of 3t will be here 2 to the power minus t by 2. Sorry, here we have to 3 minus 3t by 2, and this will be 3t between 0 and 3, or t will be between 0 and 1, and 0 otherwise. Okay, so this is the expression of x of 3t, the compressed signal. Okay, p of t is equal to x of 3t, and this will be, you see that this is 2 when t is between 0 and minus 0.5. So from minus 0.5 to 0 it is 2, and after that from 0 to 1 it is 2 e to the power minus 3t by 2. Okay, so it will be till 1, it will be 2 to the power minus 3t by 2. Okay, and it is 0 after that, and 0 in this range also. Okay, so this is the mathematical description, and this is the graph. Okay, so this completes the first part. Now in the part B, we are asked to sketch and write the mathematical expression of if this signal is expanded by a factor of 2, means we have to find the x of t by 2. Okay, this is part B. Okay, now let us define the expanded signal by xe of t, and it will be x of t by 2. Okay, so we can write it this will be equal to 2 into 2, so t by 4 between 0 and less than 3, or from less than 6 and this is 0 otherwise. Okay, so we have to plot the signal, and this will be t, this is our expanded signal xct. Okay, which is x of t by 2. So the amplitude will remain unchanged here, and this will go up to minus 3, and here it will be from 0 to 6, and this is the equation. So this will vary according to 2 to the power minus t by 4. Okay, and after that it is 0, and before minus 3 it is 0. Okay, this is 0th point. Okay, so this is the expanded signal x of t by 2. Okay, so this completes this example. So what we have seen in this video is what is time scaling, and how to find the expanded or the compressed signal. Okay, and we have also seen one example. So in the next lecture we will see the time reversal. Okay, so thank you.